Hello everyone. So today I want to discuss this question, Leetcode 3425 longest special path. I know there are probably thousand other explanations on YouTube for the same question, but I'm doing this just for my own personal documentation rather than anything else. So yeah, let's start by looking at the problem statement and then how we're gonna tackle this problem. So if you look at it, the question asks if you're given an undirected tree rooted at node 0 with n nodes numbered from 0 to n minus 1 represented by a 2D array. And each edge in this edges array will denote the source node, target node, and the weight or the length between length of that edge. So basically, if you see the first entry in this 0, 1, 2. So first we know that the root is noted at uh, rooted at node 0. So the first entry saying 0, 1, 2 means that there's a edge from 0 to the first node and the dist length between that edge is 2. So similarly, you can generate a tree with all these edges. Now, a special path is defined. So first of all, you're also given an integer array nums where num represents the value at node I. So like each node will have a value associated to it. So this zero is not the this value associated with the node, it's just the node number. So basically, node 0 has a value of 2. Node 1 has a value of 1. So this is 1. So node 2 has a value of 2 again. So if you see the coloring that they have taken is basically 0 and 2 both have the same value, which is 2. Right? Similarly, for edges, for the nodes 1, 3, 5, which is if you check 1, 1, 3, and 5, all three of them have a value of 1. And the fourth node has a value of 3. So this is represented by a different color. So they're just given the colors to each value in this case. So now what you're supposed to do, they're asking you to find the length of the special path and also the number of nodes in that special path, minimum number of nodes in all possible longest special paths. So what is a special path? So if you see, suppose this path, 0 to 1 to 2 to 5. So this is a path in the tree, but this is not a special path because uh, nodes with same value repeat themselves in the path. So 1 and 5 and 0 and 2 are in this path, and they're not like not all the nodes, all the node values in this path are unique. So this is not a special path. But if you look at 0, 1, 4, this is a special path because the first node in that path has a value, let's just say red for the time being. The second one has a value of the color of blue, and then fourth is green. So there are no repeated nodes, repeated by their values. So there are no repeated nodes in this path. And the length of this path is 6. So 6, this 0, 1, 4 is a special path and its length is 6. So similarly, you're supposed to find the longest special path in this tree, and there could be multiple special paths, like with the same multiple longest special paths, and uh, they could have the same length, right? So if you look, for example, 2 to 5, this has a length 6, and 0, 1, 4 also has a length of 6, which is the maximum in this tree. So both of them are the longest special paths in this tree. But you're supposed to choose the path which has minimum number of nodes. So 2 and 5 will be included, so making it 2 nodes, and in this 0, 1, 4 path, there are 3 nodes. So the nodes in this path are 3, in this path are 2. So you're supposed to take this path and then return, first of all, the length, which is 6, and the number of nodes in that longest special path, which is 2. So this is the problem statement. I'll go over it once more and start like trying to develop a solution for this. Okay, give me a second. Okay, so here's the question again. And yes, okay, the question asks, find the long, you have to find the longest special path with min number of nodes in it. So forget about this question for a time being, and let's try to figure this out from a different point of view. So if you're just given a linear array, a 1D array, and you're given a bunch of numbers, right? So let's say 1, 2, 1, and 2 again. In this array, if you're like if you're trying to find the sum of the lengths of a subarray with no repeating characters, how would you do it? So suppose in this case, this is the question, and you're supposed to find 1, 2, 1, 2 is the length. So with no repeating characters, there's a subarray this, there's a subarray this, and that's it, right? Because if you include this subarray, the characters repeat themselves. The numbers repeat themselves. So 1 to 1 will have two occurrences of 1. Similarly, with 2, 1, 2, same scenario. 2 and 2 repeat themselves. So this is not a special path in a case of a 1D array. So in this case, now think if these two have a length, like a length of 2 between them. So the character at 0, the number at 0 and the number at 1 have a length of 2. From this 2 to 1 have a length of 3. And this has a length of 6 between them. Just some hypothetical lengths between the characters. So how would you find this? How would you find the length of the longest special path in this case? The idea would be to have a pre-sum array, like prefix sum, and then wherever the character repeated uh, occurred before this, subtract the pre-sum till then. So if I try to create a pre-sum array for this, it will be 2, 5, and 11. Now look at this instance. Suppose you're here, okay? So you're trying to find a longest special path or some special path. You're trying to find a special path which ends at this index, 11th index. So how would you do it? You will try to find where this 2 occurred previously. So in it occurred here, right? What you would do then is subtract whatever the presum was generated before this. Now, in this case, you will have to uh, subtract the prefix sum, which is the current one, and subtract it with whatever wherever this 2 occurred before. So now just try to extrapolate this information for this path, right? How would you do it? So in this case, there'll be just imagine there's a hypothetical presum array, this 2, this 5, and this 11. And you're trying to find out the length of the longest special path ending at this node, this blue node. So what you would do is you try to find where this blue node occurred previously, right? It occurred here. So you would subtract whatever the presum presum there is right now, subtract the value generated by including this node in the presum. So you would subtract 3 and 2, right? 3 to 5, which is the previous one. So the length would be 6. So this is how I will try to create a longest special path for one path, some path in this tree. Now, just imagine what would you do to go through each path in this tree? You would use a DFS, right? Some type of depth first search. You would use it here, which will generate all these paths for you, and then find the longest special path. Now, we know we can use DFS because it will generate all the paths, and we need to keep track of some, let's say, index where this colored node uh, occurred earlier. So in this case, it was here. So you would subtract the presum 5 from this 11, like at the current index. Now, as you go back, this node will get deleted, right? This is how DFS works. So when you start backtracking, you'll remove 5 from the path. You'll try to see if this 2 has some other children. It does not. So it'll remove 2 from the path. It'll go back. And then it'll check if 1 has some other children. So it does. So it'll come down here. Now you'll be considering this path. Same things will happen for this. And you'll go back. And then you'll consider this path. So now DFS will take care of at least considering each path in this tree and then try to find the longest special path in each of the case. Now, as said, you need some idea of where, suppose you're at this node or this node, you'll need to find out where this node, this colored node occurred earlier. So in this case, at node 1. So you'll now we're just trying to find some like ingredients on how we can build up a solution. So first of all, consider all the paths that DFS will take care of, right? Now we need occurrences of each color earlier. So we need some type of map. In this case, we can just use, we'll check if blue at this point, when we process this one node, we'll say blue occurred at first position. And the map would already have map of red equal to 0. Because we had processed this node, we come down here, map red is 1 now, map blue is 1, sorry. Then you come down to this path, and you'll have, we'll see that map of 2 occurred earlier, map of red occurred earlier, but it's occurring again. So the latest position where red occurred would be red 1. So you'll delete this entry and use this. So you need some kind of map to see which, where the current color occurred earlier, right? Now, one more thing. So this, we need this to see where the colors occurred earlier and this. So is this enough? Not really, because imagine a scenario where path looks something like this. Okay, and you're in this node right now. So now, supposing we have a map already, we'll come to this node, we'll check where it occurred earlier. So it'll tell you the red occurred at this position. Suppose this position was 0, 1, 2, 3, 4. Now, will it suffice to just subtract whatever length sum we got till now and subtract this length? Suppose this was x. Will this suffice? Not really, because if you're doing this, you're considering this as a special path, right? But in this case, blue has occurred 3 times already, so this can't be considered a special path. So in scenarios like this, we need a map plus something else. Something else is another pointer called start pointer. Okay, so What this start pointer will do, it will point to the last valid starting point. So if you're here, you should be subtracting this whole part and not just this. This is very similar to how you would do it in an array. So if you consider this array and you're at this index, you want to find what is the length till now without any repeating characters. So for this, the map of 1 would say it occurred at 0, this position. But it is not enough to just subtract the presum till this position. You'll need to subtract presum till this position, right? Because uh, only this will be unique. If you include this part, 2 will occur again. So this is my start pointer, and this is my old position of this number. So now we have all the ingredients on how we go about this. So you need DFS to consider all the paths, uh, a map to consider the old positions of each color in that path, and a start pointer saying where should we start the special path from. Now there's one more caveat, which is in this case, in a linear array, we are going through each possible numbers and calculating it, and this suffices for our answer. But here they can think of it as each path being a different array. Now, if we update some map for some path, say this path, we need to change the map back to its original position when we backtrack. So when 5 gets removed, like suppose we have considered the path 0, 0 to 1 to 2 to 5. Now we need to consider path 0 to 1 to 3. Now we'll remove this 5, remove this 2, and then from 1 go to 3. So not only this has to get removed, this part, we also need to remove whatever changes got added to the map and the start pointer, right? So while backtracking, in the pseudocode, if you're considering a path, say you added uh, this path of mine will just add the presum of the path, will just add the presum of the path that we're considering. So in this case, I'll add 0 first when I include the node 0. When I go to process node 1, I'll add 2. When I go to process node 2 here, I'll add 2 plus whatever the length between them, which is 5. And then when I go to process 5, I'll add uh, 5 plus 6, that is 11. So this would be my path when I reach node number 5, right? Also, how would the position of map in the start pointer change? So when I first call my function, my start will be at -1. Okay. My map will be empty. So there's nothing in that map. So map is just empty for the time being. Now, when I process 0, what I would do is I would first check what is the old position because I might be backtracking on this node later at a later point. So first, I would just check what the old position was before I considered this node to be in my path. So I would just check map get 0, right? I and at the start pointer is -1. So I would also consider what the start was, old start, which is I'll change this to start. Now I'll check if old position is greater than or equal to start. So why am I doing this? So suppose start was somewhere over here, right? At some index, random index, and I'm like processing this element. So the old position of this element, suppose X was here. So this is the old position. So now I see, like I cannot consider the length to be from this current C, let's call it C, from start to C, because in that path, X repeats itself. So what I'm gonna do is I'm gonna check if uh, old position is greater than start, and if it is, I'm just gonna say start is old position plus one. So now the start moves to here. So now we know for sure that this subarray or this path has no repeating values in it. Okay, so what did we do? We came in and we called this function some DFS. We call this DFS with a value of start minus one and empty map. And then we took down what the when we started processing this node, what was the value of start and hold position, right? What this would do is like when we backtrack, we're gonna use these two values to revert our map and our old position, revert our map and the start position to what it was before we process this node. So you do this, you put start as old position plus one, and then try to find what the so now the presum till now is what? Or sorry, what is the special current special path length? Special length. What is it? It's presum whatever it was minus path. As I said, I'm going to be including presums in this path array, okay, or some vector. So it's 11 till now. So suppose we're in this position, it's 11 till now. We know the start is somewhere over here. It should be at this point because the last blue node was at 1, and we need to consider just this path and not the whole thing. So I'm going to subtract presum minus path, and if this current special length is greater than whatever we have for the maximum special length, we're gonna consider this as a new special path. So it would look something like this. If special path len is greater than some global max, then we're gonna change this global max to this current special path length. And also, we're gonna change global min, which is taking into account the minimum number of nodes till now, to be the current index minus start plus one. So this index can be sent to the DFS with starting from zero. So as you include more elements, it becomes zero, and the next call would be to one, next the next call two, and so on. So you can just pass this index value as another argument in the DFS. So you would call the function by presum as zero, current index as zero, some path. This is the presum path that we're like building as we go through the DFS, and then the map, and then the start pointer. We could just have a start pointer as a global variable initialized with minus one at the beginning. So the current index would be zero. And when more DFS gets called on the neighbors, it'll just be uh, position plus one. So yeah, so this would act as a position variable here. And you would have different position in a current index passed around in the DFS function itself. So yeah, so you for calculating the number of nodes in that path, you just need to do IDX minus start plus one. Else, if this C current special path length is equal to the global max, now you need to check if the nodes in number of nodes in this path is less than whatever minimum number of nodes, global minimum nodes you have till now. If it is, change the minimum nodes again. So there's no point changing the length. So only if global min is greater than this IDX minus start plus one, you change global min to IDX minus start plus one. Yeah, so to recap, this is basically just a question of finding the prefix sums or the cumulative sum in a path, and you need to maximize this path, and you need to make sure between those numbers there's no repeating values. So this would be its representation in a 1D array. But now just because it is in a tree, in a graph, we need some additional things to take care of. So DFS will consider all those paths. So just think of DFS collecting these path arrays, right? Collecting a number of 1D arrays to find the special path length in. Map is the old position. So you would do the same thing in the uh, linear function as well. But another extra point to take care of is when you backtrack, when you remove a node from that path, you also need to remove all the changes that inclusion of that node made into our maps and our start positions. So yeah, this is the idea. Now I'll just give a quick look over at the code. Okay, so yeah, so this is a path here which will consider all the prefix sums in that current path, right? So I'm just converting these edges into an adjacency list, which includes its weight as well, or the length. You could call it a length. And then I start a DFS from the current node, right? Which is 0th node, which is the root of the tree, and then pass its parent. Now, because the idea is it's a tree, right? So in a graph, if uh, you would you would require a visited array to check if all the like all the nodes that you haven't visited should not be visited again, or all the nodes that you have visited should not be visited again. So you would need a Boolean visited array, right? But just because it's a tree, we can do away with just having one variable called the parent. So when you go down to one, now you need to one's neighbors are 0, 2, 3, and 4, right? But you don't need to visit 0 again because it was a parent. That's where you came from to this node 1. So you are just fine by having by storing this parent array, parent integer, so that you don't go back to this parent, like to visit the parent again as part of visiting all the neighbors. Okay, so again, what we're doing, we're calculating the current position as the path size. So at the beginning, it'll be empty. So position is 0 right now. Old position is last nums of nodes. So this nums of node, yeah, again, I have just created a last array to instead of a map, it's just going from 0 to max plus 1, the max value in the nums array, right? So you can store it in the last, and it's initialized with all minus ones. So in this case, at the start, when you come to node 0, your old position will be minus 1, right? Old start again minus 1 because it's initialized. as -1. Now you add path presum to the current path. Right now, we've just included the node, not the edge. So there is no presum, so it's 0. So presum also gets passed around with value 0 at the beginning. So presum right now is 0, right? So you would have your path array would become 0 right now. Now you would change last of num's node, which is uh, num's node is 0, so nums is 2. So you would get last 2, which is the color red. So I'm just gonna call it color for the time being, is at 0. Okay, this is how you've changed it. Now you'll check if old position is greater than or equal to start. So in this case, -1 greater than or equal to -1, which is true. So start becomes 0, right? And the current special path length, so as we know, nothing has gotten included till now. Presum was 0, right? So it'll be presum 0 minus path dot get start, which is 0 again here, right? So current special path length is 0 because as you know, we are processing this node 0 and we haven't included any edge. So current special path length is 0. So again, as I showed you in the like just the pseudocode, this is what we're doing. If the current special path length is greater than max length, which is initialized to 0, then we'll change the max length and change the number of nodes in that path. So in this case, pause was 0, right? So pause was initialized as a path size. So 0 minus start is 0 now, plus 1. So min nodes is 1. So you've included this node into the path, right? Or if it is equal to max length and this value, the number of nodes is lesser than min nodes, you update the min nodes as well. Next, you go through all the neighbors. We'll check if that's not the parent in like if it was not a tree, we would have to see if visited of v is equal to false, then we would go into DFS. So in this case, what we're doing, we are calling DFS with this node. So in this case, now the node is 1, uh, right? The parent is the current node, so 0. Presum was 0 plus neighbor 1. So 0 is connected to 1 with the value edge weight 2, right? So this would include this edge, two two size edge into our presum. So now when we come to processing the node 1, what happened? Your path will get uh, increased by the value 2, right? You check last blue, it was what, -1. So first of all, old position would be last of blue. Last of blue was what earlier? -1. So old pos is -1. And now last blue would be the current position, which is what? 1, right? So old pos, you check, you store what old pos was. It was, I'm gonna write it again just in case I'm making some errors. So old start was what? Now old start is whatever start got changed in the first attempt. So it became 0. So the old start is 0. And then you would uh, change the path to include this 2, the current presum, which got passed with this edge, two valued edge, right? And now you check old position. Old position was what? -1, right? So blue did not occur till now, so its position was -1. And old position is -1. Start was at 0. So is this true? No, it's not. So start's not going to change. So start still stays at 0, right? So this is how we recurse through each path. And when we're backtracking, we're going to change. So when you remove a node, you want to remove all the changes associated with it that got included because of it. So last num's node would become the old position before we started processing this node. Start would become old start, and you remove the path or the presum from the path, and then find the other length. So I hope this is clear. Finally, just for a dry run, like some dry run. So we run this node 1. Now when we go to node 2, 3 gets included. So presum becomes 5. Start was at 0, right? So but we'll see the old position is at 0 and start was also 0. So this will happen. Start will become 1. So the path would be this 0 to 5 and start is 1. So you'll remove the presum generated for start. So 5 minus 2. So this length, the start is at 1 now, and we got included this 1, 2. We included this edge 1 to 2 with 3. And we had to remove this 2 because 0, the red color node occurred at the 0th position, right? When you go to fifth node, you'll see start is here, old pause is also here, so start gets added, like incremented to this node 2, and then you would have this node, this special path length as well. So yeah, I think that's pretty much it. Thank you.